Hello everyone, this problem is from GATE 2020 Electrical Engineering. A three-phase cylindrical rotor synchronous generator has a synchronous reactance XS and a negligible armature resistance. The magnitude of per phase terminal voltage is VA and magnitude of per phase induced EMF is EA. Consider the following statements. Statement P says for any three-phase balanced leading load connected across the terminal of the synchronous generator, VA is always more than EA. And statement Q says for any three-phase balanced lagging load connected across the terminals of the synchronous generator, VA is always less than EA. Which of the following options are correct? Option A is P is false, Q is true. Option B is P is true, Q is false. Option C is P and Q both are false. Option D, P and Q both are true. One can refer to the details of this topic from the NPTEL course that is mentioned here. Now, the useful data pertaining to solve this problem is percentage voltage regulation, which is a ratio of change in terminal voltage from no load to full load, and full load terminal voltage as percentage it is given here. Now, if we write it, if we denote the magnitude of generated voltage per phase as EF and the magnitude of the full load terminal voltage as Vt, then we can see this is expressed as EF minus Vt by Vt into 100. So, if we see the variation of the voltage regulation with the power factor, we can note that the right hand side is showing that the voltage regulation is always positive for unity power factor and lagging power factor loads, whereas the voltage regulation may be either positive, 0 or negative for the leading power factors, right? Now, if we use the voltage regulation curve in order to establish which of the given statements are true, let us see how we'll proceed. So, let us take statement P here. Okay. So, for leading loads, we have to see that for leading loads, as we have seen, regulation may be positive, may be positive, 0 or negative, right? So, if now I write down the voltage regulation as the magnitude of EA minus the magnitude of VA divided by the magnitude of VA into 100, of course, EA is the induced EMF per phase and VA is the terminal voltage per phase that is given in the problem. So, for positive voltage regulation, we can see from the above expression that EA should be greater than VA. For negative voltage regulation, EA should be less than VA, and for 0 voltage regulation, both the quantities should be equal, right? So, the statement P says that for any three-phase balanced leading load, VA is always more than EA. So, we have seen here that this statement doesn't hold true, as VA can be less than, or you can say greater than and equal to EA. So, we can conclude from here that statement P is false, right? Statement P is false. Let us now check the validity of statement Q. Q is for the lagging loads. Okay. So for lagging power factor, voltage regulation is always positive. Voltage regulation is always positive. That we have already discussed in the useful data. This implies that EA is greater than VA. Right? For this expression to give us a positive value, EA should be greater than VA. Or we can say that VA is always less than EA, right? So if we see the validity of statement Q, VA is always less than EA. So this is true. So we can say that statement Q is true. So with P false and Q true, our option A is correct, right? Option A is correct. So for this problem, out of A, B, C and D, our option A is the correct option. Thank you.